This is example 2 from the notes in class. And I'll start by reading the full example because, again, that's a really good way to make sure that you've gotten all the information and kind of absorbed a little bit of the problem. The next step will be to kind of highlight or circle or kind of write down just the most important numbers. And then the final step for part A would be to put that together into a linear function. And then I'll worry about part B in a moment. Okay. A controversial 1992 Danish study reported that men's average sperm count has decreased from 113 million per milliliter in 1940 to 66 million per milliliter in 1990. Express the sperm count S as a linear function of the number of years T since 1940. Okay, so let's start by highlighting the most important numbers. So 113 million per milliliter in 1940 and 66 million per milliliter in 1990. And then we're being asked to find S as a function of T. So if I just write down that stuff, kind of put it in a table or something like that. So we have 113 million per milliliter in 1940 and 66 million per milliliter in 1990. And we want to find S equals something with a T in it. Let me rewrite my T a little bit. Okay, something T. So we've been given two pairs of numbers, and these will be like X's and Y's. And again, if you look at the letter that they've asked us to use, S is going to play the usual role of Y, and T is going to play the usual role of X. So just like when we write Y equals mx plus b, here we'll be doing S equals mt plus something. Okay, one final thing to remember is that T equals the number of years since 1940. It's really important to get that because that means that when T is equal to 0, for instance, that means that it's 1940. And when T is equal to 50, that means that it's 1990. So we won't be using the numbers 1940 and 1990. We'll be using 50 and 0. Okay, let's see. Going back up to the numbers, we just need to figure out which pairs of numbers are the X's and the Y's. And I've already said, really, that the S is like the Y values. And then the numbers that are the years will be the T values, which are like X. Okay, I think we're just about ready then to put this together. We need to calculate the slope. Usually slope is change in Y over change in X. But in this case, that'll really be change in S over the change in T. Change in S will be 113 minus 66. And the change in T, and it's important to put the numbers on the bottom in the same order as the numbers on top. So for instance, when I had 113, I should use the T value corresponding to 1940. And that's going to be 0. So I'm combining a couple different things here. Which S goes with which T, but then also how I write the T, which was 1940 corresponds to 0. Okay, and then the other number would be 50. And so when you subtract this, you should get, I think, negative 47 over 50. I guess it'd actually be positive 47 over negative 50, but we tend to put the negative either on top or out in front. Okay, so I'm just about done then. S equals negative 47 50ths times T plus, and then the slope intercept form of the equation has the value b, which corresponds to what's going on at the y-axis, or what's going on when x equals 0, or finally that means what's going on when t is equal to 0. And when t is equal to 0, that was 113. So this is like the y equals mx plus b formula. And again, b is what happens when you have 0 for x or for t. So you should be able to double check that. If you plug in t equals 0, then you'd get something times 0 would be 0, and that would be plus 113, and that's the right value to start with. Okay, so that's part A. Part of the purpose of part A is to be able to do things like part B, where we make predictions. We look into the future, or sometimes we extrapolate into the past, and we see what the numbers are past the original values that they've given us. So let's read part B now. A man's fertility is affected if his sperm count drops below about 20 million per milliliter. If the linear model in part A is accurate, in what year will the average male sperm count fall below this level? So in other words, they're asking, when will S equal 20? And I guess that would be 20 million per milliliter. So this means we should take the formula for S and we should set it equal to 20, and then we solve for the other variable. So we have negative 47/50 times t plus 113 equals 20. And then we solve that. Okay, so let's see, I subtract 113 from both sides. And whoops, don't forget my t. And then simplify that. Let me grab my calculator. Okay, I've grabbed my calculator, so now I can say that the number on the right is negative 98. And then to solve for t, I should multiply by the reciprocal of this number, which is, I guess, just like dividing by that number. So this will be t equals negative 98 times negative 50 over 47. And again, plug that into a calculator. You'll get 98.9. Now that's not actually the year. This is how many years will go by. But if you go back up to what the original year was, 1940, then we're talking about 98 years after that. So the actual year will be 1940 plus 98.9. That comes out to be 2038.9. We would probably round that up. People don't usually talk about 0.9 years, so 2039 would be the calendar year. So that's part B, and I'll just go ahead and put a box around part A as well, because that was the maybe actually the more work was part A to find that equation of a line. And that's the whole example.